We live in a world of progress, where change is usually for the better. But occasionally, with the benefit of hindsight, some of the so-called advances in technology are not such good news as at first they seemed. This is a good, if extreme, example of a seemingly advanced construction becoming a danger because the designers failed to take into account all possible eventualities. In this case, the adverse effect of high winds. The purpose of this program is to make you aware of some aspects of modern building construction which are now giving cause for concern when involved in a fire. Fortunately, no one was injured when the bridge finally collapsed, mainly because the danger was so obvious that the area was kept clear. But if the weakness had been hidden, it might have been a different story. Truss plates were first introduced in the late 60s and have since revolutionized roof construction in the building industry. Before then, roofs were constructed on-site by skilled joiners, using traditional fixings such as nails, screws or bolts. But once truss plates were approved for use under local authority building regulations, timber roof frames could be prefabricated off-site, using timber with a smaller cross-sectional area, frequently as little as 35 millimeters thick. This saves both time and labor costs. The roofing truss frames are accurately assembled using jigs. And once positioned, truss plates are located either side of the joints and pushed home under pressure. A manufacturer will also use this method of fixing to butt joint two lengths of timber together to make one extended length. This particular manufacturer uses a computer-aided design system to ensure that all joints and finished trusses are safe and will withstand the projected loading. They also take great care to ensure that the correct sized plate is used and that it is positioned accurately. Some unscrupulous manufacturers may not be so careful. The completed trusses are transported to the building site where they're lifted into place. The basic construction of a roof truss consists of 3 timber elements or chords. The 2 upper diagonal chords, which form the rafters, will be under compression, whilst the lower horizontal chord will be under tension. This basic triangle is made rigid with further diagonal bracing, which also helps spread the load. On the basic roof truss shown, truss plates would be used at a minimum of 6 points. The average number used, however, would be much higher than this due to the very common practice of butt jointing. Under normal conditions, this makes little, if any, difference to the actual strength of the roof, but in a fire situation, things are different. The failure of any one of these joints would upset the stability of the truss and thus impose an immediate additional load on the other frames, some of which may also have been weakened. This may result in the complete collapse of the roof. The grip of the fixing relies on hundreds of tapering spikes, 8 to 10 millimeters long. If involved in fire, it follows that even with quite shallow charring of just 4 millimeters, the integral strength of the fixing is halved. Tests have shown that it takes under 7 minutes for softwood to char to this depth. Now, if we suppose it takes 2 minutes to alert the brigade, and 5 minutes for the first appliance to reach the scene of a fire, the structural strength of the roof could already be seriously affected just as you are entering the building. It's also considered probable that rather than protecting the joined timber, the large surface area of the fixing would readily conduct heat to the spikes below the surface of the wood, inducing additional charring in these areas. Experience is now showing that this, coupled with the reduction in cross-sectional area of the timber, increases the risk of an early collapse of the roof. Often with roofs of this construction, this would be a total collapse, bringing down several tons of roofing tiles to the floors and any personnel below. It's also important to remember that the trusses are generally designed to span the structure without any intermediate support, so there's no need for internal load-bearing walls. This also means that there's less protection inside the building should the roof collapse. Unfortunately, there is no way of identifying the method of roof construction from the outside of a building, and as domestic and commercial premises both share this system, usage is no guide either. The apparent age of the building can be misleading too. Many older factories, houses, and even churches have been re-roofed using prefabricated roof trusses. In short, we must assume that any roof involved in a fire may have been built this way, so it's essential that the correct safety procedures are adopted to minimize the risks. Wherever possible, first, remain close to walls, especially external walls. Second, avoid crossing above or below unsupported structures. Third, adopt a position close to or beneath the strongest load-bearing elements of the building, i.e. beneath door or window lintels, well-supported beams, or other substantial structural features. Timber-framed buildings also pose a risk to firefighters, that of hidden fire spread. Outwardly, a timber-framed house looks like a traditional brick-built one, but it is, as the name implies, a timber frame around which a brick skin is erected. Building regulations require that fire stops are built into the construction, but these are minimal, and as experience has shown, have often been breached. It follows that a fire, seemingly confined to a downstairs room, could possibly spread through inadequately fire-stopped cavities to involve the roof void. In the time it takes to cut away the interior wall surface to check, the roof structure may have been weakened to the point of collapse. Two further points should be borne in mind. First, as prefabricated roof trusses do not require ridge plates, securing a roof ladder over the ridge of a roof between trusses is not as secure as using the ladder on a traditionally built roof. Secondly, with these prefabricated roof structures, little allowance is made for the additional load imposed if the roof void is used as a storage area. Even if no fire situation exists, the extra weight of personnel and equipment may be enough to bring about a collapse. The partial or total collapse of a structure during firefighting operations has always been a cause for concern for firefighters. The dangers posed by stone staircases and cast-iron pillars, for example, are well known and taught during training. The increased possibility of roof collapse should now be added to that list. So remember, if a roof is involved in fire, no matter how small, the structural integrity of that roof must be doubted and the necessary precautions taken. In a well-developed fire, the sudden collapse of this type of roof is almost a certainty.